Welcome to the Energy Capital Podcast. I'm your host, Doug Lewin. Obviously, I talk to a lot of energy experts from entrepreneurial companies to investor-owned utilities, co-ops, municipal utilities, generators, retailers. One thing that keeps coming through these days in these conversations is the need for better planning to deal with rising load growth. Better planning to be more resilient in the face of increasingly extreme weather. Better planning to lower system costs and help consumers of all kinds, better planning to reduce emissions, and better integration of planning with operations to achieve those goals, both on the distribution and the transmission sides of the grid. As I think about these problems, I try to think of people who I can learn from and people for which conversations with them will help my audience understand these issues as well. And my guest on the podcast this week, Hala Ballouz, has as much experience with these challenges, system planning and operations, as anyone I know. She's the president and CEO of Electric Power Engineers, and she's built a rapidly growing team of over 200 power system engineers and energy professionals with a singular focus: holistically transforming the electric grid to enable a resilient, affordable, and carbon-free energy future. Hala envisions a future grid that is decentralized, with distributed energy resources including microgrids, distributed generation, demand response, grid edge technologies, all enabling consumers to participate in energy markets and contribute to system reliability and resiliency. It's a very compelling and exciting vision, and few describe it better than Hala Ballouz. In our conversation, we talked about the need for better planning to integrate large loads and new supply and demand resources on the grid, including AI data centers, but also distributed energy resources and electric vehicles, other grid edge technologies on the demand side. We explore the challenges and opportunities in building a clean and resilient energy grid, highlighting necessary technology and regulatory innovation needed to address congestion and curtailment issues. Hala also underscores something that isn't often talked about in these kinds of conversations. It's not all technology and technocratic fixes. There's also an increasing importance and significance for stakeholder engagement and the need to redefine reliability and resiliency requirements in ways that are meaningful and understandable to the general public. Hala is truly a thought leader, just a leader in general, a CEO of a very dynamic company. I really enjoyed this conversation. I hope you do as well. And please, 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 I know I say this in every podcast, and it's easy to just gloss over, but it really is very meaningful if you take just a minute out of your day to rate or review this podcast. Please give us 5 stars. It does help other people to find the podcast. If you are not already a subscriber to the Energy Capital Podcast, the Texas Energy and Power newsletter, please also take a minute to do that. You can find it all at douglewin.com. Thank you for listening and have a great day. Hala Ballouz, welcome to the Energy Capital Podcast. Thanks for being with us.
Great to be here. Thank you for having me.
So excited to have this conversation. You've been writing some great articles on LinkedIn, and your company is really taking off and doing some really exciting things, really at kind of the edge of innovation and so much that is changing on the grid. So you have a very unique perspective. Really excited to hear from you. But before we jump into talking I always want this podcast to be welcoming and bringing people in and this story as well. Can you talk about your background and how you came to be an engineer working on the grid?
Wow, I did not expect that. I'm excited about talking about my journey. One day I'll write a book, Energy and My Journey. It started with loving math and physics and what have you. At one point in time, I remember being in high school and talking to one of my physics teachers and saying, "What can I do with all this love of math and physics?" He said, "Electrical engineering, but it's maybe too hard for a woman." And that really was why I went into electrical engineering. It was a challenge.
When was this? At what rough time period basically did this happen, and where?
All right, this is in the late 80s in Lebanon, in a small town. called Zahli. It's the land of poetry and wine. And that's where I went to high school.
And somebody said to you, electrical engineering would be great, but it's too hard for a woman. And while, there might be people thinking, well, that was maybe just an attitude, there in Lebanon and that time, that was very much an attitude in America at that time, and to a certain extent, subtly still is. Right? I heard an engineer joke once that she knew the industry was really changing when the line at the ladies' bathroom got longer at the engineering conferences than the men's line. That it used to be she could just walk in with no line, and now she was starting to see lines, and she said, "Oh, that's a." I can't remember who told me that, but that's sort of a sign of the times. But that is a very, I think even to this day, like a very pervasive attitude. People wouldn't say that like that anymore, but it's still kind of there, isn't it? Do you see barriers to women becoming engineers?
It is still there. In my journey to build EPE to what it is today, although I never complained about it, I saw it as one of the challenges that you have to conquer in life. I had to jump through many hoops. Being the CEO of an organization, a woman CEO, I had to innovate and use different methods to join the club and be able to be seen to be bringing the value that our company is bringing truly without any prejudice. And we've done it. So when I came to Texas A&M to do my engineering degree, electrical engineering degree in power systems, my master's thesis was on large scale battery storage, technologically advanced at that point, different than anything we have today. But the cost benefits of storage on the grid reliability and resiliency and economics. And even back then in the 90s, I was able to prove that the cost benefits of something like that is important. And the key point here is that taught me that it's a holistic type of study that you have to do on the grid. You can't look at infrastructure alone. You've got to look at balancing energy, and that's what storage does. So that was, in my opinion, a corner milestone in what later my passion to renewable energy and to reliability and resiliency and affordability at the same time shaped what EPE became today, where I understood early on that you have to look at every piece and part of the system in order to develop a grid and an energy infrastructure that is reliable, economic, resilient, and now also clean. So that's how EPE is developed. EPE has over 230 power systems engineers in a company that's almost 300 people now. We're focused on all aspects of the grid. I like to always say we look like the grid. So we cater to both energy developers and load centers, renewable energy, and we also cater to utilities, ISOs, co-ops, munis, as well as regulators and utility commissions. We do this holistically where we have many departments, the transmission, distribution, electrification, digitalization. We also have NERC compliance, owner's engineer. We try to look at every project and every problem on the grid end to end.
Excellent. So yeah, so you're really doing a lot of engineering studies and planning, trying to figure out how do we integrate renewables, where are the best sites for storage, where are transmission distribution upgrades needed, those kinds of things.
Right, like we perform today over 50 interconnection studies every week.
Wow. And those are is there a higher concentration in ERCOT in Texas? Are you guys just all over the US or even global?
We're all over the US. We're even global. 95% in the US, 50% Texas, or 40%, and the rest is all over the United States. We practically do studies in every state and in every jurisdiction, but we remain 50% ERCOT.
Got it. And you began with EPE in 2007, correct? So it's been 17 years with a lot of work in ERCOT. You have seen massive change over that period. Can you? I mean, there's kind of the obvious of the rapid rise of renewables anything else in particular in ERCOT that you would highlight that has just, maybe might be interesting to the audience as far as the changes you've seen? I mean, it's a fairly short period of time in like the broad history of things, but it's a long period of time in kind of in a grid change kind of a sense, right?
Absolutely. I will first make a small correction. I've worked with EPE for EPE all my life. 2007 is when I owned it from a very small business that's lifestyle business of its owner back then. And I bought the business when it was less than 10 people and grew it since 2007. Setting that aside, which is a wonderful journey and a great company, I would say yes. So renewables, you and I were amongst the trailblazers of clean energy and renewable energy. We were there and we saw it happen. So that definitely is a big change, as you said, renewable energy. I have to say that kind of happened relatively slowly. And I like to emphasize that as we talk about other things. We yet challenging, but even though slowly it was challenging. What's different now, especially in the last year or two, is the speed at which other things are changing. In ERCOT in particular, if you're asking about ERCOT, it's the huge load growth.
Mhm.
You probably have seen from the recent board of directors meeting of ERCOT, we're looking in the next 5 years at 40 plus more gigawatts of load. That's more than half of the load we have today, or about half the load we have today in 5 years. That is unprecedented. I like to also parallel that. That's not only in ERCOT, but it's good to look at ERCOT because it's its own microgrid in the United States and its challenges are unique. We're seeing that load growth in data centers in particular. The dynamic nature of the load is also different. And these data centers, how they behave, the distributed resources, how they behave, and the change in the behavior of load at the consumer level is also something we see nationwide as well as in ERCOT. We saw that in the Storm Uri, where the estimated load was different than the actual. So all these things are very, very important. Also, we've got the energy market that we developed quite a while ago that has some mismatches with the current needs and the capacity needs in ERCOT. We've got regulatory frameworks that are starting to misalign with the current reality of things. Market volatility, congestion has been growing faster than in the past 17 years or 15 years. Storage is growing very fast, which is good. We're growing in potential very fast, but we still don't have large scale storage that ERCOT needs. So we have some challenges in this area. And of course, like anywhere else in the US, there is some aging infrastructure issues that we're facing.
That is a lot right there. Thanks for that. So a lot of different ways we could go from there, but I actually think I wanna stay with this, what you just called the dynamic nature of load and these rising projections of load growth. And I do want to be clear because I think there's a lot of discussion out there, and I think it's healthy discussion as to whether or not this load growth will actually materialize. I think it's important to point out that we have already seen massive load growth. This is not just a future phenomenon, right? I mean, we came into the summer of 2022 having never crossed 75 gigawatts in ERCOT, hit 80 in the summer of 2022, hit 85 in the summer of 2023. So this rising load growth is not just some future projection. It is already happening. What I want to dive into, though, is what you just described is that dynamic nature of loads, the ability to have shifting loads. And we'll get into a discussion here also of distributed energy resources, but that in and of itself is a distributed energy resource. Can you talk a little bit about the kinds of loads that are coming in and the potential, both among the large loads and potentially on the smaller side, for load shifting and what that means for the reliability, the resiliency, and the affordability of the system?
All right. So first, the large loads. We're looking at large loads that you mentioned we haven't seen before. Interconnection request for a 500 megawatt or a gigawatt of a data center load, or a hydrogen production load. That's things we never dealt with before. That's requiring a whole different type of study. A different There isn't enough infrastructure in place to accommodate this load, and the speed at which this load wants to come will probably is outpacing the ability to build the infrastructure in time. So that's a challenge by itself. Well, flip it on the other side on flexibility. I think load flexibility, and flexibility in particular, and grid enhancing technologies are going to be key in order to bridge the gap between the time we can build the infrastructure to catch up with this type of load growth, and that could be in existing large loads, in mechanisms to do that. But I definitely advocate looking at the grid edge and the ability to leverage the grid edge in this flexibility, and to couple that with the ability to build microgrids around it, and meet some resiliency needs that we have to tackle.
So you mentioned grid edge, and I think that most listeners of this podcast will know what that means. But I do want to. I always want this podcast to be welcoming and bringing people in that. And this is, I know, a big mission of yours, Hala. Right? Is your engineering transition newsletter, which is great. And I hope folks will check out on LinkedIn. We'll put a link to that. That you're trying to make that accessible and bring some of these terms. So let's talk a little bit. What do you mean by grid edge? And then I want to talk a little bit about something you wrote about that, but go ahead.
Yes. So let me talk about decentralization, right? And it's an introduction and really it is the grid edge in a different way. We are at the very early stages of a new world in which the customers and their assets play an unprecedented role on the grid, whether rooftop solar, smart water heaters, batteries, or electric vehicles. The customer side of the electricity ecosystem is rapidly becoming populated with grid interactive devices. Example, just look at the Ford F-150 Lightning with vehicle to grid battery and technology, or look at Tesla pilot projects on aggregating batteries at the consumer level to play in the wholesale power market. That's what we're talking about, the grid edge. Extend that a little further. It is really your thermostat at home, right? Your water heater at home. All of that collectively can make a very large percent flexibility of the grid need for generation. We can offset 10-20% of the electricity need without building infrastructure if we leverage all of that. And this is happening already. Nationwide, more in the West, some more in the East, more than currently in ERCOT, if you're asking about ERCOT. But it is a must, and a need that we have to become really good at.
And you're saying right now, just to make sure I understand you clearly, that those kinds of technologies, and this flexibility of demand, you're seeing happening more in other markets than you are in ERCOT currently, or the other way around.
Yeah, yes. Other markets, like look at the West, or markets that there has been policy and regulatory construct to incentivize solar rooftop, and other grid edge. Again, back to this word grid edge, which means consumer based energy resources and electric vehicle speeding electric vehicle adoption. They naturally are seeing more activity there, and starting to develop programs around it that leverage this flexibility of load, and also manage the disruption from this type of load and resources at the grid edge if you don't do it right.
Yeah, and so the grid edge, right? It is an evocative term. It sort of should paint the picture, I think, in people's minds. Like, we're literally talking about, what is the grid? How do you define the grid, right? A lot of people will say, well, it's poles and wires, it's power plants. And I think what has started to happen over the last decade, and that's increasing in the last year or two, is that the grid is also inclusive of all of these different things that are quote unquote at the grid edge, things like solar panels and battery storage and electric vehicles, but also things like, as you said, electric water heaters and pool pumps and thermostats. All those things are at the grid edge too. And you had in one of your pieces on LinkedIn a graphic which I really like, which sort of like drew a circle of the grid, and it kind of had the grid edge outside of the grid. And the change that you're seeing and describing is that circle is being widened and that grid edge is being brought into the grid as an asset, as a resource. Did I describe that well, or
You
how?
did.
Yeah, add some more to that, because I hadn't really seen that image before, and I think it's very, again, kind of evocative of what's happening, that these devices are, and even our homes and buildings, we almost have to think of in the same way we think of power plants and poles and wires as being an actual part of the grid.
That graphic you're talking about was homemade at EPE, so that's why you haven't seen it before. Long gone are the days where electricity was one direction, flowing from large generating power plants and going all the way to consumers whose behavior was very predictable, right? I mean, think just 50 years ago, there was just the light bulbs, right, in our homes, and that's all we needed to worry about, and the fridge and other things. Now we're talking about bidirectional power flow. That's why that graphic you're referring to in my newsletter or blog, you see it growing and becoming inside the circle of what the ISO even has to worry about. The ERCOT, the MISO, the SPP, the CAISO. It's no longer on the edge where we used to just think of that load that we need to serve it and build the entire system to serve it without even worrying about what's happening behind the substation. Right now, it's all interactive and within one big circle.
Yeah, exactly. And I love the way you put this in your newsletter talking about DERs. You said that the future state of the industry, in my opinion, is going to require loads and DERs to be that's distributed energy resources, to be active stakeholders in balancing the grid, just like bulk system generation resources currently do. Utilities are transitioning from grids that have historically received their power supply from large power plants at the transmission level or the bulk system and served, as you just said, passive, predictable load on the distribution level. And then you said, and I love this, the transition rather has begun in earnest, and there's no turning back. The seams have begun to dissolve. And that's really where it was like, it
Yes.
used to just be, here's the generation, here's the lines of serve, here's who is passively receiving that power on the other end. And there was a pretty clear delineation and division there. And now it's really starting to all kind of blend together, where, as you said, you have these two-way power flows. And while you said, the ISOs didn't used to have to worry about that, and they do have to worry about it, there's some serious challenge, but it can also be a resource to those ISOs, right? When you talk about 10 or 20% coming from load, in a place like ERCOT, we're talking about, 8 to 15 gigawatts. Like, that is a massive amount of a resource that could be available to help them do their jobs, to keep the lights on. What do you think at this point are some of the barriers? I know you talk a lot about bringing more people into the process of planning and things like that. Is it getting people more involved? Is it a regulatory barrier? Is it an engineering barrier? All the above. What is sort of standing between us, being able to really tap into those resources to lower costs and increase reliability, and where we are today?
Absolutely. So it is all of the above. So think about the holistic study of this system, and let me emphasize planning and dial back just a couple of notches back in our discussion and say I've always sat there looking at how we are managing and planning for our grid. And I have seen over and over again planning being not front and center. and we need to change that. It's usually, the big dollars are going in operation and in all the equipment that's going in there and how to operate, and we can no longer operate like this. We've got to think about planning, especially now that it's challenging. Now, what's challenging planning more than ever is the type of studies we have to do are different as well. We have not done those before. Utilities have not done those types of studies where you don't even have the tools that can take the distribution system and dynamically put it within the transmission system. So there are serious challenges there. And by the way, that's why people like EPE have spent all their lives thinking about how to solve that and finding innovative ways in software and automation to do these things. But there is also regulatory constructs that are in the way. You may have seen that in some of the ISO forecasts and planning, load that's not committed was was not part of what's allowed to go into a study, and we can no longer do that. We have to know that these things are coming, even if they're not committed with an agreement, that we have to put them in the types of studies. These are one of the simplest things that regulatory has to address. But going back to what we call the grid edge and talking about consumer and leveraging these hundreds of megawatts of potential that could be the replacement of infrastructure and storage projects, we need to think about the concept that allows us to do that. You've got consumers on the edge, you've got to recruit them, put them together. You've got to participate in the wholesale market. You got to be compensated on the value that you're providing, and all of that regulatory and market incentive construct needs a lot of work. It wasn't built to leverage that, and we need to work together to do this. That's number one. There are many, I'll just do two. Number two, it is different now, although it's great that we're a deregulated market, and deregulated means, generation works in its own construct to make itself affordable and valuable for the grid. Transmission alone, distribution alone, in more ways than one. We have different regulatory constructs around these. Now we've got to sit together and do things called integrated resource plan. In this resource plan, you've got to think of the large generators, which we're good at. You've got to think now about these large dynamic loads. You've got to think about the grid edge load, the electrification that's adding a lot of load on the grid edge, but also that collective batteries and EVs and solar rooftop, and how does it participate in this integrated resource plan? We need most of all to sit together, and we're starting to see that, but we don't have the construct around it where we sit together and we say we can no longer wait until it happens, until the load comes. We're going to sit together and say, hey, this data center can go here, this large generator, we need it over there, this aggregate load in this region, I'm going to take it into account and I'm going to depend on it. And that's the only way to balance a system, is by working together and build a plan somewhat ahead of time. It's like going back to a hint of a regulated construct of how we used to do that.
Well, and this is really fascinating. This is a really, really rich vein because there is this kind of tension in ERCOT, right? There is a very strong market ethos, right? We want competitive forces to shape the market for the good of consumers. And I think overall, in most ways, certainly not all, that has worked pretty well, particularly on the generation side. And we have seen the
Right.
cost of generation going down. Now you're in a world where there is all this, as you referred to earlier, right? All this load coming in. And if you're going to accommodate that load, you not only need generation, you need the transmission and distribution too. And the transmission and distribution is not a competitive function. That is very much a regulated function. And so now you have this tension between the dynamic market forces on the generation side and the imperative to have really good forward thinking and planning on the T&D side. So you mentioned integrated resource planning. So on that same point I'm making about that kind of tension there, right? A lot of places throughout the United States, and I presume around the world, I don't actually know, but certainly around the United States, they do have integrated resource plans, but those are done by integrated utilities, utilities that have transmission, distribution, generation, and retail all together. We don't do IRPs, integrated resource plans, in Texas, at least in the deregulated areas. I guess not even in the fully integrated areas in Texas. I don't think we do IRPs. But I think there is a real need at this point for DRPs, for distribution resource plans, because that distribution grid is changing so fast and has to accommodate all this dynamism we're talking about, new loads and data centers plopping down right in the middle of a distribution grid. They're not always plopping down, right? You would know this more than I would, but what I'm hearing from folks is they're not always plopping down out in West Texas. A lot of them are, for instance, in South Dallas or something like that. So, and then add to that all you were saying about electric vehicles and all the things on the grid edge. This distribution resource planning piece strikes me as absolutely critical. Of course, the transmission piece is too. I assume, I don't actually know, but based on what you've said so far and some of what I know about your company, is this a lot of what you guys do? And if so, like what are you seeing as far as trends in that space?
Absolutely. So, first on distribution planning, since you asked about our company, we actually spent the last 10 years building software, starting with the distribution side that granularly models everything behind even the meter on the consumer side. You can model everything. And we built that in anticipation of what you're talking about, the need to take the collective resources, not just the loads, the static loads, and model them in your planning. And that integrated distribution resource planning is happening across the grid, and we're helping a lot of customers with that. That is key and very important because you've got to model these varying loads. It's something called 8760 analysis. It represents, if you've heard that, it's 8760 hours. There are 8760 hours a year. In the old days, which is, now, yesterday, we used to do the studies by looking at a snapshot in time, saying, this is when I peak in the winter time. I'm going to study the winter time peak and the summertime peak and do the study. Now you've got to do this hour by hour, if not 15 by 15-minute analysis, in which you layer the variability of all the resources on the consumer side and the CNI side, and you build your system, your resources, and your infrastructure while looking at that. And to the surprise of many, even the planners sitting at utilities, they look sometimes at these and they say, wow, you're telling me I was looking at the wrong moment in time to plan my future. I should have been looking at, 3 p.m. instead of 7 p.m. or whatever it is. And that is key, because if we don't plan correctly for what's needed, we're going to end up in more of those instances we talked about earlier, which are disruptions and not having power during extreme weather conditions or mildly extreme conditions.
Yeah, and that 8760 is so interesting because when you really start to dig in, particularly the ERCOT market and the volatility we're talking about earlier, typically happens on a few hundred hours out of the year. So that's really where, if you think of like, if you can move your load around 1 or 2% of the year, that's 87 or 180, 190 hours out of a year. That's really the number of hours typically, not every year. And tell me if you're seeing different things in your models, but that's typically the number of hours where you have a whole lot of scarcity. So if you can get that 10 or 20% of load in just for that small number of hours, you've made a huge difference on the grid.
Absolutely. And flip that on the side of affordability, right? And keeping things affordable while all this is happening, you need to leverage what you have first instead of building infrastructure for 1 hour a year or 50 hours a year or whatever number of hours a year. And the more we have on the grid edge, on the distributed distribution side, the more these numbers of hours
Yeah.
are going to increase,
Yeah.
because the variability is going to increase in ways that we now cannot imagine. on a daily basis. So we've got to address those, and we are able to address those, but we don't need to build infrastructure for 1 hour a month of scarcity.
It's so this is great. So let's keeping with this theme of resource planning. We just talked about the distribution grid. Let's also talk about transmission, because obviously there's that is another place where planning is absolutely essential, because as we're dealing with very acutely right now, and not just in ERCOT but really all around the country, I think all around the world, as you mentioned earlier, these big loads of 500 or 1,000 megawatts can show up pretty quickly. And that's not the usual thing. Usually, if somebody builds a big manufacturing facility, big factory, think of a semiconductor plant like Samsung builds in Texas, right? Those take 4, 5, 6, 7 years to build, and you have time to catch up with transmission. Some of these data centers are being plopped down in a 6 or 12 month kind of time frame, and to build transmission, it takes 4, 5, 6, 7 years. So now you have this mismatch. So can you talk a little bit about the transmission side? And I know you have been a voice very, active out there talking about grid enhancing technologies. You already brought it up in this conversation, but let's talk about those two things, both sort of being able to get more out of the transmission grid that we have. So kind of from the operations side, like how do we get more out of what we have? And maybe there's some hardware associated with that too. We should talk about that. And then that longer term planning and what the transmission needs you're seeing, specifically in ERCOT, but you can certainly talk about other places because I think it's interesting to compare and contrast. So let's talk transmission planning a little bit. Easy topic, right?
All right. So easy topic, exciting topic. First to just transition from our last conversation on distribution planning, just imagine all that complexity of 8760 hour by hour work on the distribution system. First, transmission needs to look at that as well. That's necessary, and all of that variability on the distribution system needs to be taken into account, and that alone is a bucket that needs to be tackled. And that's why at EPE we have actually hired a great new leader in our company, and she's focused on integrated T&D planning because it is a big topic, right? How do you do that? Then go to the issues you mentioned there. A big data center comes, right? Uh, how can you just take a 1 gigawatt that's going to come in 2 or 3 years and develop the grid around it? I will tell you one thing. I am seeing a trend of private networks now that may be a temporary solution. How is that going to evolve will be very interesting depending on how we study it. Are we going to do it ad hoc basis? So private networks, meaning that load is coming, another generator is feeding it with a small network if needed to connect it to, right? Why would that be happening? Because there isn't enough time to do that. And I want to take you back to the days of CREZ, the competitive uh,
Yep.
renewable energy
Mm-hmm.
zones, right? Um, the other day I was just sitting by myself thinking, are we going to need to do that for data centers? Because at that time, what happened with a lot of renewable coming in is said we can't play chicken and egg. We don't know where they're going. So the Public Utility Commission said, "Hey, we're going to do this. We're going to figure out where they're going to be built. All the resource developers are going to tell us where. So we're going to work again together as stakeholders to figure out what that happens." So there is a lot of work there that needs to be done. And there is also the concept of hybrid projects, where you co-locate storage and solar with the data centers. So all these things are being looked at as possibilities. Challenges create opportunities, right? To do that. But we cannot build, that's the challenge. We cannot build a grid that's holistic, that's the entire ERCOT grid or any other large ISO grid quickly enough to integrate such large load centers without 6 7 years of time, because that's how long it takes to build this transmission infrastructure.
It's very interesting, the analogy of CREZ, because I think ERCOT is actually taking some steps towards that. They actually, at the regional planning group a couple of weeks ago, put out a map of what they were calling generation hubs. And
Mm,
this is where, again, I think there's this really interesting tension between the transmission and the generation. And like transmission, to a certain extent, to a large extent, has to be centrally planned because, again, it's a generally a monopoly function. It's not generally competitive. There are some exceptions, but by and large, that's how it works. And so you have to plan ahead. But then when you get into, as ERCOT seems to be starting to do, these generation hubs of picking the kinds of generation, I that's where, at least in my view, that's where that sort of central planning goes too far. But I do think that there is a need to kind of say, here's the parts of the state where we are seeing the market wanting to invest in generation. Can we put transmission and distribution there that basically sends a signal to the loads that, hey, if you do want to come here and be part of this great competitive ERCOT market, these are the kinds of zones where we can tell you the infrastructure is going to be built. And Texas kind of maintains that open for business kind of attitude, as opposed to saying, these loads are too big, which a lot of markets are right now, right? I mean, I don't know if you're seeing that around the country, and I'm not asking you to name names, but I'm hearing anecdotally there are parts of the country where they're being told, don't come here. We're not, or you have this really long list of things are you seeing that in different parts of the country?
Absolutely, and not naming where and which states we are seeing that. And the good thing about EPE is that we work on both sides. That's why we can see things from both sides. We even work for the loads that want to find a place to interconnect,
Yep.
right?
Yep.
So I empathize. We understand. We try to solve it on both sides. But when you take yourself and put yourself in the shoes of a utility, I mean, they've got to say no or much later. It's a matter of time. It needs time to plan, study, cost effectively, because we can't, we don't want to end up with stranded assets or ineffective assets, and the time it takes to permit and do all what needs to be done to build the transmission and distribution needed to transmission. Now we're talking to meet those load needs. So I want to be bold and say that I feel that centralized planning where ERCOT or the ISOs, and I'm not following that very closely. My people are, but I saw what the regional meeting was doing, and I think at a point you have to understand if the transmission utilities and the ERCOT are requested to react quickly, there has to be some certainty and some decision making. I That's what I really am advocating, the back to the future a little bit, is like just to catch up now. Can we all agree agree on where the most critical generation should go? Maybe not exactly where, but that's why I allude to the GRES. It's saying, this is where can you go there, and there's incentive there because there is reliability needs and load meeting needs, and the load, that's where we can serve and meet load growth, and other areas we're not going to be able to do that fast enough. There has to be some harmony orchestrating this to ride through this current stage, which we are lacking transmission and generation to meet the load.
No, I totally agree. I think that there needs to be the question is really, it's really a question of balance and sort of where do you kind of turn the dial and set that
Yes.
as far as the
Yes.
planning versus the competitive, and where the only thing, and I'm not asking you to agree or disagree. This is just my view. Where I think it goes too far is if ERCOT starts to pick the form of generation, because when I first heard
Right.
Pablo Vegas, the CEO, I've interviewed on this podcast before, and he's interesting, thoughtful guy. He first set out his vision for generation hubs to the ERCOT board. And the first thing I thought was, that's a great idea, because we need to have, just to the discussion we're having, like, you need to be able to send a signal to the market that we're open for business. It's going to be in these conditions, in these places, because there's also the matter of physics, right? You can't just take all these large loads everywhere all over the grid. Where I think it goes too far is if ERCOT starts to then pick the generation source, which they did on the slide they put out a month or two ago. They're like, it's going to be all gas. It's going to be 1,375 megawatts at 8 different sites, and it's all gas. Well, a lot of these customers, particularly the ones with big data centers, have very strong preferences for renewables. So now you may be saying we're open for business, but now you might be setting them to a point where they don't want to come here as much, and that's where I think the market really needs to bring its own dynamic forces in, and that's where I don't think. But again, you can certainly react to it if you want to.
Well, but I have to say, I recommend going more general and layer up. And that's one of my team members and thought leaders in the company in a discussion a couple months ago stated that, which I loved, is put the right requirements in place. Like, I need this type of system regulation capability, and let the resources decide what to do. So ask for the components, whether it is fast response
Yes.
or reserve or whatever it is, and let the technology figure it out. So if it is solar plus storage, so be it, right? Or if it is gas, so be it. But yes, I agree with you. So that's where I agree with you. We need to decide how far we go, but the most important part is set the metrics of reliability and resilience, and let then the market solve it. And I think we agree on that. So we need to push a little further down to talk to each other, but not too far to drive away technology that we really need to grow.
I think that's well put. And because also you don't know what new technologies are going to come in. So you need to set the attributes you want. What are the qualities you want out of the system? And
Yes.
then you might be surprised by some of the solutions that come in that are things that we don't where, you build that transmission, it takes 6 years. In 6 years, there's going to be who knows what happens with enhanced geothermal or small nuclear, or like, why pick that?
Absolutely.
So I do want to come back to grid enhancing technologies. Y'all do work on that as well. I mean, so how I hear so many different things that it's a 10% improvement, which would be great. That's huge. But I've heard 40%. I've heard 100%. Like, can you talk a little bit about the technologies involved? Because there's different aspects of it, right? There's the advanced reconductoring and dynamic line ratings. What are some of them you think are most promising, and just on an order of magnitude, like what the impact of upgrading the grid with these grid enhancing technologies could be?
Well, I hate to not give you precise numbers or answers, because what I want to tell you, it's very location
Hmm.
problem specific, right? That's why one of the important first major roadblocks to adopting grid enhancing technologies that you mentioned are the type of studies that need to be done, which we're trying to focus on. There's even DOE initiatives to explain how these studies need to do, because we're not used to doing these studies and they're different, right? Again, they're granular. They need to take into account all these conditions that these grid enhancing technologies will do. But I mean, at the end of the day, yes, it is a significant amount of impact. It could be 10%, it could be more in terms of more capacity, getting more capacity out of the line. It depends on what you're doing. Some technologies can get you a whole lot more than that. The dynamic line rating, if you're mitigating a few hours a year of a certain overload of a line, which with dynamic line rating, it actually shows you that you can ride through that. The benefit of that is really the dollar amount in offsetting other infrastructure you have to build to accommodate that. So there are different levers that you're pulling in that perspective. And while we're talking about this, I'd like to take the opportunity to say I also would love to start seeing storage being allowed to be a transmission and a distribution asset, because it is one of the most powerful grid enhancing technologies. You can think about it as a resource, which is great. We're building with our clients all of the energy storage, which are really treated like solar and wind because they're, store that energy and then sell it back to the grid. But as a transmission or distribution asset, they are needed. This is what you can do to offset overloads of lines and to provide energy in times that it's needed. So we have not, it's been years and we have not seen much advancement on that. And my study in the 90s was based on storage being an asset.
It's very interesting. Yeah, very interesting. So Encore, the large utility, of course, for Dallas Fort Worth area and for big swaths of West Texas, had proposed. I think it was might have been the 2015 session. It was a long time ago now, to have a big program of buying storage and putting it all around the T&D system as an asset. That was not passed by the legislature. There's always been this is another point of tension, right? In the ERCOT market, storage, which is neither fish nor fowl, it's not really generation, it's not really a T&D asset. Where does it fit? But to now, it has always kind of stayed on the generation side. I don't know if you've thought about, like, does that occur as a competitive function where generators are still owning it and then the T&D companies contract with them for service? Or do you think the T&D utilities would actually like own and rate base the storage?
Look, I don't go into these details, but I definitely advocate not one or the other. That would be a mistake. You can't say, no, now it's going to be a transition distribution asset and the generators have no play. Absolutely not. I think, and I've read, and you have construct where it is both. Let me put for you a simple simulation of how that looked like. And to me, it applies across also to the grid edge. We're talking about to batteries in homes and EVs. I think the stakeholders, the generation developers, the storage developers, the consumer at home, me, my electric vehicle, I think I should be able to participate in the market the way I like. I believe there should be a certain something that looks like a certain 10%, 20%, 50% of what I have that I commit to the grid as an asset to use. And that's where everybody wins, right? The developer still develops. We have the competitive market to have them bring the best technology. They're the best to know about how to manage it and operate it, etc. But there should be some commitment of a piece of it that brings the utilities and the ISOs the certainty of having that much of that asset to use. And I don't think, I mean, I say it as if it's easy. I mean, when you come to regulatory, it gets more complicated, but we should believe that we can do it. There is no reason why we can't do it.
Yeah, I agree. And then you have the benefit to the grid of that storage, but obviously also that homeowner or small business owner also has storage at their site, that if the grid goes down, when we're recording, there's still some people in Houston that are down from the storm that moved through. And so if you have that storage at your home, you then know that you at least have some power to get you through those kinds of events. So there's this kind of multiple benefit win-win kind of situation there.
Exactly. So I own an EV. If I know ahead of time that 70% of my battery, and I buy my EV and my battery knowing this is it, 70% of it is mine. And at any point in time, the grid can block 30% for the greater good, right? And then I'm being paid for that 30%, but I don't sit during a storm and say I'm going to use it. It's not mine. It's blocked. But here we both created an infrastructure, and going to the let me pivot here a little bit and tell you
Sure.
there was a panel at one of the last conferences I went to with Tesla, Google, and other private companies talking about uh, virtual power plants and
Yes.
how they're going to provide those. And we had a discussion after the meeting talking, and they were very tuned into the fact that eventually we should all be thinking about energy as a service. And that's a whole other topic. I probably should add it to our newsletter, to my newsletter one day, or you and I can talk about
Yeah, I
it.
want to read that one already as soon as you publish it. Let me know.
Yeah. Absolutely. So we need to think like that in order to all win together.
No, I think that's exactly right. So I have a lot more questions on transmission, but I'll just ask one more. So obviously in Texas over the last couple of years, we've seen a very large increase in congestion. Can you talk a little bit about, as a planner and as somebody that is doing these grid studies, what are the more promising solutions to handle that? Because, and to describe that congestion, right, is where you have a lot of renewables, and it does not just renewables. There can be congestion for any kind of source, including thermal, but where there's a lot of generation and not enough capacity on a line, you can get congestion, and then curtailment, where that amount of the full amount of generation can't flow to where it's needed. It's effectively wasted. And we're seeing on the order of like hundreds of millions of dollars a month worth of power, literally billions per year, of power that is effectively wasted. What do you think are the more promising solutions to handle that problem?
So these, again, I go to planning, and we are seeing more of our customers work with us. So we're not built and done. We're looking ahead of time. So as a generator and a load on a grid in a market like ERCOT, which is still mostly all an energy market, right? You've got to know that these risks exist. Um, so you need to be looking ahead and preparing for those things and working proactively to see if there are solutions with the utilities and ERCOT years ahead of time. But that being said, these congestion issues are going to continue to come, especially now that load is growing very fast and we don't have the mechanism for building capacity. So we're going to be short on generation, but at the same time, we don't have the construct to incentivize the generation to be built with the uncertainty in the load that's being added. So we've got to solve the market structure and the market incentives to solve that. Otherwise, we are going to continue to be seeing those problems. That's my opinion. There is also other solutions if we want to talk about taking things into your own hands as a developer, of going in and making hybrid solutions to your projects, right? Adding storage, doing other things, going to data centers and see if they can co-locate with you to offset some of the load needs, or other types of load. Hydrogen, if we know ERCOT is going to be expected to be a hydrogen producing state. So these solutions are necessary to fill the gaps. Of course, grid enhancing technologies as well. If your problem is not very huge, you can go and have someone do a study for you to see if you can go to the utilities and work with them to propose such solutions and see if that solution can be implemented to alleviate the overloads on those lines that you're seeing. Now, why would you have to go to do that? In my opinion, as a generator, well, you're the one that's hurting the most, and the utilities are still figuring out how to do those studies. We've seen it over and over again, even from the days of building renewables early. That's why people like us exist. You come and you do your own homework while the utility is busy dealing with other things and day-to-day things, and you come with a solution and say, can you help me implement that? That's in the short term. The long term is we need to tackle the energy market and the incentives to build more generation and transmission.
So if you could do an upgrade, whether that's something like advanced reconductoring or something along those lines, you could then accommodate more of that generation coming through the lines. You mentioned storage or co-locating demand. So that in that situation, you would basically be saying, okay, congestion is happening. It's a fact of life. I'm going to use, instead of just wasting that energy, I'll store it. And then when there is
Mhm.
capacity on the line, then I'll move it through using the storage. Correct. So those would be a couple different solutions.
That's right.
Okay.
Absolutely, and co-locate load, like you said, while you're bringing it out to ERCOT and others, the needs of more incentives, market incentives to justify that cost as well. So it's not one side only, right? We need the market to incentivize and give value to these grid enhancing technologies or storage or other services that we're going to have to provide to solve the problem, they should be also compensated so it can be affordable.
Let me also just ask, you mentioned hydrogen. Are you seeing as a increasing part of your business, are people wanting studies done on hydrogen and how it might work, particularly in ERCOT?
Yes, there is a lot of study in ERCOT on hydrogen, and we study it as any load addition and resource addition. There is co-location and hybrid projects. In other states, we're seeing a lot of, we're involved in pilots, like in Illinois with the university and the utility there. Ameren, we're doing hybrid projects where some of them are extending to also being part of it being buses and other fleets being on hydrogen as well, where you have hydrogen production, you've got all the other elements. So we're seeing this microgrid type of study that includes hydrogen as a resource to more than one function.
Cool. Just a couple more things before we kind of wind down here. I do want to ask you about this is one of the things you put on the list of things you want to write about on LinkedIn. So we'll look for this article as you roll it out too. But you can give us a little preview. You mentioned you want to cover how existing regulatory and governance structures might need to change as we embark on this journey towards a clean energy future. Can you talk about that a little bit?
Yes. So, it, I started with the concept that you and I discussed now of going back and embracing stakeholder engagement. Right? We don't have a construct for it. That needs to be embraced. But there is one component that will be very important when I speak about that. It is really the reliability and the resilience requirements. They need to be revisited. The resilience in itself, which we're facing now everywhere, in the last 10 years, it's been a hit or miss of near blackout in many states across the US, right? This is going to be very important to define resilience and redefine reliability and work with the stakeholders and constituents together on that, not only because of all that you and I talked about and the changes that are happening that are different, but because with electrification of transportation, with the electrification of everything, with you and I and our children, grandchildren not being able to do their homework if there's no electricity, to my car needing electricity, we need to up our reliability requirements because more we depend more on electricity than the days when we set those reliability standards. So there's a whole lot to cover there, but that's a glimpse.
There's a whole lot to cover there, but I love is kind of the central theme there, really involving people more in this process because it is it just as you were describing earlier in this discussion, sort of a one-way grid. If you're going to have a two-way grid, that implies that should imply it should require necessitate that the people that were sort of passive recipients are now much more active participants. They need to not only be active participants in the grid, but in these regulatory and governance structures
Totally.
to make sure it works for them.
Absolutely. So that stakeholder engagement and working together. Look, we are rolling up our sleeves. There's a reason why this is called energy transition. It's not because it's fun. It's amazing that we have that opportunity. Its challenges are huge, but it's an opportunity to redesign the system from scratch. And a lot of times you hear me say we're gonna like sweep everything off the table, roll out our maps and say, how would we build this as stakeholders all together, you and me, my EV, and the data center, and the renewable generator, the transmission, the ISO, everybody? How would we have built this if we started from scratch, right? And then, and only then, we would understand what we're up against in this energy transition. And then hopefully we will start working together to build towards it. And when something massive changes like this, people have to work together.
Yes, absolutely. So I know we've talked about a lot of it, but maybe this is a good way to kind of summarize it. There's a few questions I like to ask most, if not all, guests. So one of those is, what does the grid look like in kind of a 5 to 10 year kind of a period, and how is it different for consumers? So again, acknowledging we've talked about a lot of it, but maybe to kind of summarize, where do you think this is all headed when we wake up and call it 33 or something like that. What is when my now fourth graders are graduating high school? That would be 2032. They reminded me today. What does the grid look like? And how is it different for consumers?
So first, a couple of things before we go to consumers. I did speak about that in a keynote, and I loved it because I'm passionate about it. We've got to think future in order to build what we need, right? Not 5 years, 10 years, 20 years, 30 years. Uh, I'm thinking there is more wind. It hasn't slowed down because we have found more efficient ways to produce wind. We also have mitigated impacts on migrating birds. We have maybe expanded into small turbines that we can that can capture speed on very low speed of wind on building rooftops. In 20 years, solar panels are everywhere, not just in the fields on our rooftop. They are in our fences. They are in our clothes. We have to think like that. Then we must, at that time, we have significant storage in innovative ways. It could be hydrogen, it could be other than hydrogen. But if it's hydrogen because we know about it, I can imagine having an electrolyzer at my ranch, right, where we have small ways in which we can produce storage at our homes, and we're all microgridding together to serve the grid. Now, the grid edge. So the consumer, how does it look different for the consumer? On the consumer side of the meter, enormous changes have occurred in 2035 is what I like to look at. In some regions where grids have taken on a more fractal nature. In this future, especially the case when extreme weather has threatened the reliability of power everywhere. We know it's happening. So you and I and everybody are thinking, how are we going to be resilient as a community? Therefore, microgrids will become abound at that time. But so too nanogrids, where small communities or homes or CNI are doing that. Millions of homeowners have taken advantage of the bidirectional power flow of their Ford F-150 or their batteries, their EV, their solar rooftops, and they are supplementing all of that with resources of their own. Neighbors transacting energy with each other, and their resources serving their communities to shape their resiliency. So I'm looking at the future where we start the community up and we start solving both resiliency, clean energy, sustainability, together at the same time, and overcoming climate change, starting by building grid of grids where the microgrids around communities are really driving people to interact. And that in itself, which will be one of the topics that I will talk about, when you start with communities, you will start really finding ways to solve equity issues because people will support each other for the greater good of a community. Where you and I may be able to afford adding storage, somebody else may not, but hey, I'm willing to pay for it for the greater good of having a grid that will support me and overcome the cost burden on some other people in the grid. So the future is a stakeholder interaction in its true sense, where everybody works harmoniously with each other, but taking it down and solving it from the bottom up is where we should go.
That's an amazing vision. I'm so glad you've shared that. I have so many questions about that. We're going to have to do a follow up second podcast at some point.
Absolutely.
I do want to ask you one other question too, though, because we talked about it a little bit before, and I know you've got an interesting answer to it. What is something that is conventional wisdom among energy people you think is wrong or commonly misunderstood?
Yes, and it's not a very fun one. It's cost, but I think that needs to be come out in the open. And I don't want to say that other energy professionals don't know it, but we should not dance around it. The aging infrastructure by itself, the aggressive load growth, the climate change, the electrification, not only for the purpose of clean energy, but electrification because technology is there. Look at my desk, how many pieces I have. All of that together, there is no way we can build double the system size that we have today without a huge cost. And most of that cost, whether it's clean energy or transmission or distribution or other things that we put in play, most of it is huge capital investment upfront. So we've got to figure out a way to understand that it's going to come with a cost, and how to make it affordable is how to work together innovatively with regulatory construct and other incentives and policies, so that we can truly spread that cost over time, where I am sure in the long term we will reap the benefit of that only if we build it right. So cost is one. And another one that we talked about is the myth that the load can continue to be treated, you and I, our homes can be continued to be treated as a passive load, and that we build a bubble around it, and we treat it like that. We are the consumer. They're already in. They're a stakeholder. There's no way back. Once I bought an EV, once I put solar on my rooftop, once I see what's happening with climate change, I've got to recruit myself as a stakeholder. So we've got to start boldly thinking about that differently, and not continue the path of saying, all right, we've got to think of this the way we always thought about it.
For sure. And I actually think there's a huge connection between those two things too, Hala, because the rising costs, if you have the ability to participate on the grid edge as a participant in the market as part of an aggregation or what have you, you then have some ability to lower that bill because you're being compensated for those assets you have on the grid. And we have to give more opportunities for folks to reduce their bills if they want to. There'll be a certain segment of the population says, not interested. I'll just pay whatever the rising bill is. There's going to be a
Exactly.
much larger group, I think. They're going to say, raise their hand and say, no, I want to be part of making the grid stronger, of bringing flexibility to the grid so we can decarbonize and to lower my bill. If even one of those things is a motivation of yours, and I think for
Yeah.
most people, all three will be, we've got to give them the opportunity to participate. It's just going to become more and more critical, right?
Absolutely. And that's where, when we talk about where regulatory can play and how to build markets and structure around this, is it really going to be me and you figuring out how to cost participate and do it? Is it going to be energy as a service? We've got to figure that early, so we can spark plug it or get it to start really much faster than
Yeah,
we can just doing it ad hoc, right? But
absolutely.
but
Yeah,
you and I,
absolutely.
like you said, maybe if I want to reiterate that, you and I are motivated to do that because we want a reliable and cost effective, and we want our lights on, and we want to contribute to clean energy. So all of us have a stake in it, whether it's cost, whether it's clean energy, whether it is worrying about the reliability. We all have motivation to do it, and we need to build the construct to make that happen.
Beautiful. Thanks, Hala.
I'm very excited to be part of this show.
I'm very excited that you were with us. Thanks so much for doing it, Hala. This is great. Thank you for listening to the Energy Capital Podcast. I hope you enjoyed the episode. If you did, please like, rate, and review wherever you listen to your podcasts. Until next time, have a great day.